Constituents of the atom. The nucleus of an atom contains protons and neutrons. Collectively, these are known as nucleons, so protons and neutrons are both nucleons. We can represent this with a symbol. This has got 1, 2, 3, 4, 5, 6 protons, making it a nucleus of a carbon atom, so it has the symbol C. We can also add numbers to this. We can add the atomic number, which is the number of protons, given the symbol Z down here. So as we said previously, this has got 6 protons. Up here we're going to put the mass number. This is given by the number of protons and neutrons and is given the notation A. Here we've got the 6 protons and we also have 1, 2, 3, 4, 5, 6 neutrons. So the mass number is 12. If we were given a notation something like this and asked to work out how many neutrons the nucleus contained, well, the top number A is the protons plus neutrons, the bottom number just the protons. So A minus Z gives the number of neutrons. The negative electrons of an atom are found around the outside of the nucleus. An atom has equal numbers of protons and electrons, and so overall it is neutral. But an ion has a charge because it has either gained or lost electrons. It's only the electrons that can be gained or lost, not the protons. Looking at the properties of the different particles, first the mass in kilograms. The proton has a mass of 1.67 times 10 to the minus 27 kilograms. The neutron has virtually the same mass, the same to 2 decimal places here, at 1.67 times 10 to the minus 27 kilograms. The electron is much smaller, with a mass of 9.11 times 10 to the minus 31 kilograms. Relating these to the mass of the proton has a mass of 1 proton mass, a neutron a mass of 1 proton mass, and the electron virtually 0 or 0.0005 times the mass of the proton. In terms of charges, in coulombs, the proton has a charge of plus 1.60 times 10 to the minus 19 coulombs. The neutron, as the name suggests, is neutral, and the electron has exactly the same magnitude but opposite sign as the proton at minus 1.6 times 10 to the minus 19 coulombs. This is why in an atom, when you have the same number of protons and electrons, the atom itself is neutral. Relating these to the charge on the proton clearly has 1 proton charge, the neutron 0, and the electron minus 1 proton charge. The charge in coulombs, well, the proton is positively charged at plus 1.6 times 10 to the minus 19 coulombs. The neutron, as the name suggests, is neutral with 0 charge, and the electron has minus 1.6 times 10 to the minus 19 coulombs. So the proton and the electron have the same size of charge with opposite signs. This is why if you have the same numbers of protons and electrons in an atom, the atom itself is neutral. Compared to the charge on the proton, a proton clearly has a charge of 1, the neutron 0, and the electron minus 1. Here's the nucleus of carbon we met previously, and here we have another nucleus. This has got 1, 2, 3, 4, 5, 6 protons, the same as this one. So it must also be carbon. But this has got 1, 2, 3, 4, 5, 6, 7, 8 neutrons, and so it's not quite the same as this one. This one has got just 1, 2, 3, 4, 5, 6 neutrons. In terms of the numbers, it has 6 protons, so the Z number down here will be 6, but 6 plus 8 is 14, so it has a mass, or A number, of 14. These two are isotopes of carbon. Isotopes have the same number of protons, but different numbers of neutrons. They are both still carbon because it's the number of protons that determines what element an atom is. Here we have a selection of different nuclides, or types of nucleus. We have carbon-12 here with 6 protons and 6 neutrons. We have the other isotope, carbon-14, that we met earlier with 6 protons and 8 neutrons. We have oxygen with 8 protons and 8 neutrons, and nitrogen with 7 protons and 7 neutrons. Now to look at specific charge. This is simply the charge to mass ratio, or the charge in coulombs divided by the mass in kilograms. It can apply to nucleons, that's protons and neutrons, or ions, that is atoms that have lost or gained electrons, or electrons. Let's look first at the proton. Well, we showed earlier that the proton has a mass of 1.67 times 10 to the minus 27 kilograms and a charge of 1.6 times 10 to the minus 19 coulombs. So it has a specific charge of 9.58 times 10 to the 7 coulombs per kilogram. Now let's work out the specific charge of an ion of copper having lost 2 electrons. Well, the charge will be 2 times the charge on the electron, which is 3.2 times 10 to the minus 19 coulombs. The mass of copper is 1.05 times 10 to the minus 25 kilograms, giving a specific charge of 3.05 times 10 to the 6 coulombs per kilogram. And finally the electron. Well, this has a charge of minus 1.6 times 10 to the minus 19 coulombs and a mass of just 9.11 times 10 to the minus 31 kilograms, giving it a huge specific charge of minus 1.76 times 10 to the 11 coulombs per kilogram. Because of its tiny mass, the electron is the particle with the largest specific charge.